Today's lesson is on inequalities in one triangle. For part A here in these two examples, we're going to write the measurements in order from smallest to greatest, least to greatest. Part A, we're going to compare the sides. In order to do that, look at the angle measures. Angle C is the smallest angle measure in this triangle, so we go opposite that angle. Side AB will be our shortest. The next smallest angle is angle B, 55 degrees. Go opposite angle B. Side AC is our next shortest side, which makes the third side the longest, BC. Part B, this time we will compare the angle measures. Looking at the side lengths, side 11 here, DF is the shortest. Go opposite of that, we have angle E, which will be the smallest angle. The next smallest, we look at side EF, which is 12. Go opposite, angle D is our next smallest angle, which makes angle F our largest angle. The exterior angle inequality theorem. If you recall, the exterior angle theorem told us that the measure of the exterior angle 1 equals the sum of the two non-adjacent interior angles, angle A plus angle B. The inequality theorem tells us that the exterior angle 1 is going to be greater than either of those two interior angles, the non-adjacent interior angles. So angle 1 is greater than angle A. Also, angle 1 is greater than angle B. Triangle inequality theorem, very important. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. We have three examples here. In this first example, we can see two of the sides have a length of 2. If we were to extend those sides and move those, we don't make it all the way through. The only way we can make a triangle is if we bend that side on the bottom, length of 5. We only come up with 2 here, 2 there. We need at least 5. Looking at part B here, if we extend and shift those other two sides around, we have a length of 2 and a length of 3. They equal that third side. You no longer have a triangle, you have a line. Part C, we can tell here the lengths of 2 and 4. If we add those together, they are greater than 5, so we can form a triangle. You can compare all three cases. We already said 2 plus 4 was greater than 5. If we take side 4 plus side 5, that's going to be greater than the third side 2. If we take side 2 and side 5, that's greater than side 4. So all three cases work. We do have a triangle with side lengths 2, 4, and 5. Two sides of a triangle are given. We want to describe the possible lengths of the third side. To do this, we'll let x be that third side. X has to be in between two specific lengths. It has to be greater than the difference of those two sides, which is 6. And it has to be less than the sum of those two sides, which is 14. So that third side has to be between 6 and 14. It cannot equal 6. If it did, we'd have 4 plus 6, which equals 10. You're back to that case where it forms a straight line. The same goes if it was a length of 14. We take side 4, we add it to 10, that's going to equal 14, so once again we get a straight line. Any case in between will work. Anything greater than 14 or less than 6 will not work. For example number 2, our x has to be in between. We're going to subtract those, 25 minus 9, which gives us 16. We're going to add those. 25 plus 9, we get 34. X has to be in between 16 and 34. Example 3, our third side has to be in between. We'll subtract those to get 5. We add the two given lengths, 19. And last example 4, our third side has to be greater than 7, but less than 9. A little bit of review. DE is going to be parallel to AC. You can see FE will be parallel to AB. If AB equals 21, then EF will be half of that, 10.5. If BE equals 7, DF will actually equal the same, 7. If DE equals 10.2, then AC is 20.4. We double that. Going back to our mid-segment theorem. For 6 and 7, number 6, if YZ equals 2x plus 3, and MN equals 5x minus 14, we are looking for the length of YZ. Before we can do that, we have to find the value of x. Two ways to set up this equation. We can take the 2x plus 3 and set it equal to half of 5x minus 14. Or, instead of that, we can double that mid-segment, the 2x plus 3, and set it equal to that parallel side, 5x minus 14. Solve for x. Once you find x, we can substitute that in to find the length of YZ. And get a length of 43. For number 7, we can use a similar process. Yx equals 3x minus 4, MO equals 9x minus 20. I'm going to double xy and set it equal to MO. This time we're looking for the length of MO. Take your x, substitute it back in. Next section, 5.6, inequalities in two triangles. The hinge theorem tells us that we can compare two sides or two angles of two separate triangles. We can notice here we have two triangles. We can see that side SR is congruent to side WV. We can see side ST is congruent to side WX. If angle S is 100 degrees, angle W is 80 degrees. We will look opposite those angles and compare those opposite sides. 100 is greater than 80, therefore RT is greater than VX. Some more examples. Comparing side BC to side EF, we look at the angles opposite them, compare 42 degrees, 37 degrees. 42 is bigger, therefore BC is greater than EF. Part B, comparing side JG to side JI. If we look opposite the sides to the angles, 62 is larger than 50, so therefore JI will be greater than JG. Part C, this time we're comparing angles, angle M and angle N. We look to the side opposite, each one has 3 marks. We know they're equal, therefore angle M is equal to angle N. To solve this problem, start by drawing a picture. We have two triangles, triangle ABC and triangle XYZ. They tell us AB is congruent to YZ, side AC is congruent to side YX, side BC is 9, XZ is 11, angle A is 47 degrees. What are the possible measures for angle Y? Well, if we compare, BC is 9, XZ is 11, 9 is less than 11, so therefore we need an angle measure that is greater than the 47 degrees. 53, part D there is our only option.